Welcome to Maths with EJD. We are still talking about generating functions, and in this video, I'll be talking about advanced applications and inversion of probability generating functions. And the objective is to learn how to use probability generating functions to solve more complex problems and to understand how to invert probability generating functions to recover the probability distribution. So, you are given, usually what we've been doing is you have a probability mass function, and from there you get your generating function, right? But what if you have the generating function and you're expected to recover the probability distribution or the probability mass function, right? So that's the business we're here for right now. So let's talk about the inversion of generating functions. Okay. Um, to recover the probability mass function from the probability generating function, we can use the power series. We can use the power series expansion. Okay. And then it should be known that the coefficients of s raised to power x in the series expansion, in the series expansion of the PGF give the they actually give the probabilities, just like we know that, to get the generating function, right, you use the probabilities as coefficients of s raised to power x. And to recover these probabilities, just look at the coefficients of s raised to power x. That's all. The coefficients of s raised to power x in the series expansion of the PGF give the probabilities, which is px equals x. So let's take an example. So given the PGF GXS equals 0.2 plus 0.5s plus 0.3 s squared. Find the probability mass function of x. So, and this is all about inversion. Okay. So let's see how this works. All right. Um, so we know we are going to extract the coefficient of s, right? And that is what we have to do now. So we go for the solution. We have the solution. So for the solution now, we have the probability with the PGF, with the PGF GXS equals 0.2 plus 0.5s plus 0.3 s squared. Okay. We can rewrite this as GXS equals 0.2 s naught plus 0.2, I mean 0.5 s raised to power 1 plus 0.3 s squared. And since we know that the probabilities corresponding with each s is actually going to give us the PMF. So for instance here now, this 0.2 is the coefficient of s raised power 0. So that means that 0.2 is going to be our P naught. Okay. And this is P1. And the coefficient of s raised power 1 is our P1. The coefficient of s raised power 2 is our P2. So with that, we can now write out the probability mass function. Okay. So the probability mass function is probability that x is equal to 0. That is simply 0.2. Probability that x is equal to 1. That is 0.5. And lastly, probability that x is equal to 2. That is 0.3. And of course, that obeys the rules of probability. If you add up everything, it gives you, so you see P1 plus P2 plus P3 actually ends up giving you 1. Okay? So these are the probabilities. These are the probabilities associated with each value of the random variable x, confirming the distribution. Okay, now can we take another example? So let's take another example. The PGF, probability generating function of a random variable, x is given as gx of s equals 2 plus 3s divided by 5. So the question is to find the probability mass function. It's more like you are retrieving the probabilities. So what all we need to do is to to have whatever expression we have, get it back in series form, and extract the coefficients of s. So the solution here, given gx of s equals 2 plus 3s divided by 5. So we expand gxs in terms of powers, of s. That's all we need to do. So if it's whatever the expression is, just expand it in terms of the powers of s. So to do that now, we just know that we have gxs equals 2 plus 3s divided by 5. So that is more like 2 over 5 plus 3 over 5s. So if you can write that better, and that will be 2 over 5 s raised power 0, plus 3 over 5 s raised power 1. And just like we saw before, 2 over 5 is the coefficient of s raised power 0. So this will be P0. And 3 over 5 is the coefficient of s raised power 1. This is P1. So with that now, we can go ahead and say that um, the coefficients, the coefficient of s raised power x in the expansion would actually corresponds to probability that x is equal to x. Okay, so in that case, we know that for x equals 0, that means the probability that x is equal to 0, and that is simply 2 over 5. And then for x equals 1, that is probability that x is equal to 1, and that is 3 over 5, just like we noted, from the expansion. We can now say, therefore, the probability mass function is P of x equals 0, and that is 2 over 5, which is the same thing as 0.4. And then we have probability that x is equal to 1, that is 3 over 5, which is the same thing as 0.6. Again, if you look at the two, you see that what we can call this is P1, this is P2. So you see that P1 plus P2 would always give us 1. And that's good. So with this, we come to the end of this particular video, which is about the sum of independent random variables. And that's how it goes. So whenever you have your generating function, just expand it in series form and extract the coefficients of S in their powers like that. And then you would have got your PMF back. All right. So that is the end of this. If you have not subscribed to this channel, go ahead and do that. And for those who have subscribed, thanks a lot. Then hit the notification bell after subscribing so you can get alerted each time a new video is released. Comment. Let me know how helpful these videos are to you. And let me know if there's a question you'd like me to solve or a topic you'd like me to teach. Also, like and share so that more people can have access to this great teachings. Bye.